All right. Today what we're going to do is we're going to look at solving rational equations. And I have the first rational equation up here, and it says to solve and to check each solution. And my question to you is, why do you think you're going to check, or why do you think you're going to need to check each solution? What? Okay, and what part of it might not work? What do you think you might be looking for, John? Yeah, remember we can't have a 0 in the denominator, so you really want to keep clear on that. Now, this is the first kind of rational equation that I want to show you. This one takes a little less work, I think, than the other ones that I'm going to show you, because if you notice, it's just a rational expression on this side equal to a rational expression on that side. So essentially a fraction equal to a fraction. And you guys already know how to solve these. What do you have to do to solve something like this, Sophie? Yeah, just cross multiply, okay? So you know how to do that. So 5 times the quantity x squared minus 1 equals 15 times the quantity 2x minus 2. And I'm hoping from there it looks pretty familiar to you. So let's see, it would be 5x squared minus 30x plus 25 is equal to 0. And what could you do from there? Do what? Divide by 5, right? So we would have x squared minus 6x plus 5 is equal to 0. Does it factor? X and x, 2 pluses, 2 minuses, or one of each? Yeah. Make sure after you factor, you check. I've been seeing some incorrect factoring going on. But it has to multiply to a positive 5, so we are going to use negative 5 and negative 1, making your answers x equals 5 and, yeah, why just 5? Why does 1 not work? 2 times 1 minus 2 is 0, right? So that's not going to work. Okay? And, yeah, 1 squared minus 1 is also 0. So your answer is just 5. Okay? So if you just end up with a fraction equal to a fraction, all you need to do really is do this cross multiplying. Now, probably you've guessed that that's not going to be the only way that these are going to work out here, right? Probably you're not going to just have a fraction equal to a fraction. There's going to be a little bit more to it. So let's look at this one. It says when an equation has a sum or difference of two rational expressions, you can use the least common denominator to simplify the equation. And I'm going to show you how this works. So here's your equation. Go ahead and write this down. 1 over 2x minus 2 over 5x is equal to 1/2. Let's do what we've just been doing over the last few days and find the least common denominator. The only difference is now I have an equal sign and I have a right-hand side as well. So in addition to the fractions that I have over here being added and subtracted, I've got the answer over here that I need to consider when I talk about my least common denominator, because I want it for all 3 of my fractions. Okay? So the LCD in this case is going to be what? 10x, right? Does everybody see that? Okay, now, I know you know this, but I want you to think about it. You know that when you have an equation, as long as you do the same thing to the right-hand side that you do to the left-hand side, doesn't the equation stay balanced? Okay, so what I'm going to do after I find that LCD is multiply both sides by the LCD. Multiply both sides by the LCD. Okay, so first we find it, then we multiply by it. Now, when you multiply, make sure you use parentheses over here on the left. And distribute. And this 10x is like having 10x over 1. Now, I'm going to write down this next step that I'm writing down. I think a lot of you will get to the place where you do this step mentally, but I want to write it down so that you see it. Okay? 10x over 1 times 1 over 2x is 10x over 2x. Do you agree? Okay. Minus, when I distribute over here, I get 20x over 5x. Do you agree? Okay. And over here, I'm going to get 10x over 2. Do you agree with that? Okay. Here's why it's really nice to multiply by the least common denominator. Because after you distribute and you multiply each term by that LCD, look what happens to each term. What happens? Every term does what? Simplify, right? It reduces. This first one reduces to 5. The next one reduces to 4. The next one reduces to... Now tell me about that equation. Yeah, it is, isn't it? So if you can get rid of all those fractions when it simplifies, then it should become a relatively easy equation to solve. So x is 1/5, and there's your answer. Okay? Do I need to worry about the denominator being 0 for those? No. Okay? Now you can still plug it in. 2 times 1/5 is 2/5, and 1 over that would be 5/2. And then you're going to have 5/2 minus, what would that be, 2/5? And then check to see if that is equal. I'm sorry, minus 2. Yeah, sorry. 5/2 minus 2 is 1/2. So that works, right? Okay, any questions on that? Yes. You're multiplying the whole thing by the LCD, but when you multiply by 10x, it's like multiplying 10x over 1. And when you multiply fractions, you multiply straight across. Tops by tops, bottoms by bottoms. Okay? So let's try another example. 4 over x minus 3 over x plus 1 is equal to 1. Okay. So, Nate, LCD, can you tell it to me? Perfect. Does everybody see that? Now, Brady, what do I want to do with that LCD? Not only both terms, but both sides of your equation. Very good. Now, you may be to the point that you know when you multiply 4 times x plus 1, and that's all going to be over x, that you're going to be left with just what? 4 times the quantity x plus 1 minus, when you distribute here, do you see what you're going to be left with? Just 3x equals x times the quantity x plus 1. Do you see how it eliminates those fractions for you? Now we're just going to multiply things out and combine like terms and see if we can get this in an equation, get this equation in a form that we can solve it in. So let's see, 4x minus 3x is x, so I get x plus 4 is equal to x squared plus x, which means 4 is equal to x squared. Therefore, x could be, what is it? Thank you, plus or minus 2. Could you plug those in and check them? Are they going to make the denominator 0? Nope. Okay. Any questions on that? Okay. So let's take a look at this one. 4 over x minus 3 is equal to 2 over x plus 1 plus 16 over x squared minus 2x minus 3. So why don't you write that down first. Ideas on what we might have to do first on this one. Maddie? Factor that last denominator. Any guesses what it probably will factor into without even doing it? Guesses? Zach? Yeah, chances are it's going to factor into x plus 1 and x minus 3. It doesn't have to, but check that, because a lot of times that works. Does it? Yes. x minus 3 and x plus 1. Making your LCD equal to what, Taylor? That's it. And so, Emily, what do I need to do now that I know my LCD? Yeah, multiply each term by that LCD. So multiply this by an x minus 3 times an x plus 1. And do the same thing to this side over here. Multiply it by the x minus 3 and the x plus 1. So on the left-hand side, when you multiply that, what are you going to be left with there, Seth? Very good. 4 times the quantity x plus 1 is equal to, okay, on the right-hand side, Shelby, what are you going to be left with first? Very nice. Plus, what am I going to have there next? Let's see. Natalie? Just 16. Yeah, good. Do you see how it turns into this nice linear equation now? Okay, so go ahead and solve it. So let's see, we'll have a 2x here. Add the 6 will be 10. Subtract the 16. I guess I don't even need to subtract the 16. I want to subtract the 4, don't I? So 2x equals 6. X equals 3. Ah, yeah. Does 3 work? No. If that's the only possible answer I can get here, then what do we know about this equation? No solution. There's nothing that's going to make this work. Okay? Any questions on that? Okay. Take a minute and do this one on your own. 7 over x squared minus 5x plus 2 over x equals 3 over 2x minus 10. Am I doing okay so far? Did I do okay? Did you get the answer? For those of you who did it? Yes. So I factored all my denominators, right? You always want to factor first. I pull out a common factor and a common factor. Then I started with this one and I wrote down all my factors, x and x minus 5. Then I looked at my next fraction. It has a factor of an x, but it was already included. So then I look at my next one. It has a factor of a 2, which wasn't there, so I put it in. And then it had a factor of an x minus 5, but it was already there. Okay? Does that make sense? Okay, any questions on these? Okay, the nice thing is when it's an equation and you can multiply both sides of the equation by that LCD, it gets rid of the denominator for you. And so as soon as you get rid of the denominator, it makes things just a little bit easier. All right, then I want to look at this, word problems. So it says the aerodynamic covering on a certain bicycle increase a cyclist's average speed by 10 miles per hour. The time for a 75-mile trip is reduced by 2 hours. What is the average speed for the trip using the aerodynamic covering? Okay. So I guess my first question is this. What kind of an equation do you think we're going to use for this problem? It's talking about 75 miles. It's talking about this time being reduced. It's talking about a speed. What kind of a formula does that lead you to? It's rate times time equals distance, right? Doesn't it? You've got some rates, you've got some times, and you've got some distances. So we're just going to set up a chart. And I think you've done these before. I think you might have done them in Algebra 1. Wow, that was a collective groan. Now we've got two kinds of bicycles, I guess, that we're looking at. We're looking at the bicycles with the cover, right? And we're looking at bicycles without the cover. And let's just see if we can fill in bits and pieces of this chart. So do you know anything about either with or without the cover, the rate, the time, the distance, anything? John? With the cover, it's what? The rate is? Okay, it's x plus 10, or can I use r? So this is r plus 10, leading me to believe that that just must be r, right? Without the cover, it's r. With the cover, it's 10 miles an hour more. Good. Shelby? Okay, with the cover, it's t minus 2 hours. That means that without, it's just some time. Okay? Zach? Yeah, the 75 is just the distance, isn't it? It's 75 miles, both with and without the cover. So it's 75 there and 75 there. Now, as soon as you've got that chart filled out, you can really get two equations. One equation is r plus 10 times t minus 2 is equal to 75. And the other one is r times t is equal to 75. And it's asking us to find the what? The rate? Isn't that what it said? Yeah, find the average speed, which would be the rate. So we want to solve this equation for r. Now, we've got a system of two equations with two variables. What's a method that you can use to solve a system of two equations with two variables?
Substitution.
Substitution. So which equation do you want to pick and which variable do you want to solve for? Sarah? Yeah. Okay, you could make it r, but if you make it r, when you plug it into the first one, you're going to have all t's. And you're trying to find r. You're trying to ultimately solve for r. So probably we should solve this one for t. So make this one t equals 75 divided by r. Because if you plug that into your first equation now, you're going to end up with r plus 10 times 75 over r minus 2 is equal to 75. Now, yes?
Couldn't we substitute for the 75?
You could. The problem is you would have one equation with two variables. And you wouldn't be able to solve it because you would have two unknowns in one equation. And you need to get it to one equation with only one variable. You see what I'm saying? Okay. All right, what do you think we're going to have to do first to solve this one? FOIL it. Okay. That's just going to give you 75 minus 2r plus 750 over r minus 20 is equal to 75. Okay, so do you agree that that's going to be negative 2r plus 750 over r is going to equal, subtract a 75 and add a 20, won't that just be 20? Now, this is just like the equations we just got done solving. Find your LCD, multiply by the LCD on both sides, and you're going to end up with now we're going to try to solve that. I'm going to move everything to the right-hand side, so I have positive 2r squared plus 20r minus 750. What? Sure, we can divide by 2, right? So we have r squared plus 10r minus 375, right? Now it's just a matter of factoring this thing. I know I'm going to have one of each sign. Plus 25 and minus 15. That means r could either be negative 25 or positive 15. But what did r stand for again? The rate, so which one makes sense? The 15. 15. And now if you go back up to your table, 15 is the rate without the cover, so the rate with the cover would be 25. Okay? Could you find out times now if you needed to? Yeah. I mean, you know that this rate times this time has to be 75. If the rate is 15, then the time must be 5. And if this time is 5, then this time must be 3. Okay? They didn't ask for time, but you could pretty easily figure it out, I think. Okay. Let's see. Yes. Whoops, that's not what I wanted here. Okay, I'm going to put this up for now.